In this video, we're going to talk about more complicated improper integrals. So let's try to evaluate this improper integral. In order to do this, we need to first take the antiderivative or integral of 2 over x squared plus 4x plus 3. Now, if you remember, this is a partial fraction. So in order to integrate this, you got to first break down 2 over quantity x plus 3 times x plus 1. And you need to decompose. So a over x plus 3 plus b over x plus 1. And we need to find what a and b is. So we're going to multiply by the LCD, which is x plus 3, x plus 1 to each term. And you end up getting 2 equals a times the quantity x plus 1 plus b times the quantity x plus 3. Let x equals negative 1. Then a goes to 0. You end up getting 2 equals 2b. Therefore, b is 1. Now let x equals negative 3. So this part goes to 0. And you get 2 equals negative 2a. Therefore, a is negative 1. So what I'm going to do is I'm going to put negative 1 for a, 1 for b, and you end up getting integral of 1 over x plus 1 minus 1 over x plus 3. That whole thing to dx. Now remember though, we're going from 0 to infinity, so I'm just going to say 0 to b for now. I will write the limit later on. First, let's integrate. When you integrate this, you're going to get natural log of absolute value of x plus 1 minus natural log of absolute value of x plus 3, and from 0 to b. And using the property of natural log, you're going to get natural log of absolute value of x plus 1 over x plus 3. Okay, now let's put limit as b goes to infinity. So what do you get over here? This is equal to limit as b goes to infinity of natural log of absolute value of b plus 1 over b plus 3 minus natural log of, plug in 0, you get 1 over 3. So what happened as b goes to infinity? Okay, let's just focus on b plus 1 over b plus 3 and we'll worry about natural log later. As b goes to infinity, right, you get infinity over infinity. Let's just focus on b plus 1 over b plus 3 as b goes to infinity. So it goes to infinity over infinity. Then we could apply L'Hopital's rule, and you get 1 over 1, which is going to be 1. Or just look at this. They have the same degree, so you could just compare the coefficients. Either way, you get 1 over 1, which is 1. So as b goes to infinity, this thing inside right here goes to 1. And what is natural log of 1? Is 0. So you end up getting 0 minus natural log of 1 over 3. And if you remember, it's going to be negative natural log of, let's put quantity right here. Using the property of natural log, this is natural log of 1 minus natural log of 3. And what is natural log of 1? That's 0. So negative times negative is positive, so you end up getting natural log of 3. So therefore, the answer to this integral, improper integral, is natural log of 3. Now we're going to evaluate this integral over here. Now, if you remember, let's just focus on the integral of x e to the x dx. How are you going to find the integral of this? You have one function and you have another function over here. So it looks like we have to use integration by parts. But remember, sometimes we could use tabular method. So we're going to put x over here, e to the negative x. If one of them, if you keep taking the derivative of them and you end up getting 0, we could apply a tabular method. So what's the derivative of x? It's 1. And derivative of 1 is 0. So we could apply tabular method if we could keep taking the ni derivative, or integral of e to the negative x. So what is it? It's negative e to the negative x. And integral of that is e to the negative x. So we're good to use tabular method. Let's draw the arrow. And then put sign, positive, negative. So integral of that will be, multiply this out, you're going to get negative x e to the negative x. Multiply this out, you're going to get negative e to the negative x. Well, you have to usually put c plus c. But since this is definite, we will ignore c later on. So what is that? Well, that's going to be limit as b goes to infinity of integral of that, which we just found, negative x e to the negative x minus e to the negative x, and we don't need plus c because this is definite, 1 to b, where b goes to infinity. So we end up getting limit as b goes to infinity. Let's plug in b, negative b e to the negative b minus e to the negative b minus the quantity, plug in 1, negative e to the negative 1 minus e to the negative 1. And let me erase this part right here. So you get limit as b goes to infinity. This is like negative b over e to the b minus 1 over e to the b plus 1 over e plus 1 over e. So you get limit as b goes to infinity of negative b minus 1 over e to the b plus 2 over e. This is constant and real, so you don't have to worry about this. What about that one? What happens as b goes to infinity? Well, you end up getting infinity, actually negative infinity over infinity, isn't it? So we could apply L'Hopital's rule. Also, which one grows faster, e to the b or negative b minus 1? Polynomial over exponential. Well, you already know that exponential grows faster. So you know that this thing will go to 0. Because if you apply L'Hopital's rule, that's going to be negative 1 over e to the b. And as b goes to infinity, this will go to infinity. So negative 1 over infinity is like 0. So that goes to 0 as b goes to infinity. So what happened? We end up getting just 2 over e. So that is the final answer for this improper integral. So here we have to apply L'Hopital's rule. Before we talk about next example, let's review the graph of arc tangent of x, which is the same thing as this notation right here. These are the same notation. What happens as x goes to infinity? As x goes to infinity, the arc tangent approaches pi over 2. What about as x goes to negative infinity? Arc tangent or inverse tangent is approaching negative pi over 2. And you understand why we had to review this before I talk about next example. Now let's take a look at this improper integral. This time it goes to negative infinity infinity. That means we have to break it into two improper integrals. So we need to choose a nice number between negative infinity to infinity. Usually 0 is a nice number. Let's plug in 0 over here and 1 over 1. So it's defined. So let's break it down to negative infinity to 0, 1 over x, 1 plus x squared dx, plus integral from 0 to infinity, 1 over 1 plus x squared dx. Now, we could rewrite this as limit as a goes to negative infinity. And what's the integral of 1 over 1 plus x squared? That's our tangent, isn't it? From a to 0 plus limit, now b goes to infinity, of our tangent of x from 0 to b. So you end up getting limit as a goes to negative infinity, arc tangent of 0 minus arc tangent of a, plus limit as b goes to infinity of arc tangent of b minus arc tangent of 0. You know the arc tangent of 0 is 0 because tangent of 0 equals 0. So this is 0. And what about that one? What happens as arc tangent as a goes to negative infinity? As we talked about earlier, is going to be approaches negative pi over 2. Plus, and what happens as arc tangent of b as b goes to infinity? It approaches pi over 2. Then minus 0. So therefore, we end up getting 2 pi over 2, which is pi. So answer to this integral is pi. So therefore, it converges. Now let's take a look at this example. You got to be careful here because our trouble spot is at 0. What happens when you plug in 0? You get 1 over 0, which is undefined. So what we need to do here is we need to rewrite it as limit as a approaches 0 from the right side. Because think about it. You're going from 0 to 1. This function is undefined as 0, so you have to approach 0 from the right side. And then you got to do integral of a to 1 dx over radical x. Now let's just focus on integral of dx over radical x, which is the same thing as integral of x to the negative 1/2 dx. How do you find the antiderivative of that? It's going to be x to the 1/2 divided by 1 over 2, which is the same thing as multiplying by 2 on top. So this is the same thing as limit as a goes to 0 from the right side of 2x to the 1/2 from a to 1. So let's plug it in. You're going to get limit as a approaches 0 from the right, 2 times 1 to the 1/2 minus 2 times a to the 1/2. You know that will go to 2. What about this one? As a approaches 0 from the right, this a is getting very close to 0. So you end up getting 0 over here. So it's 2 minus 0, which is just 2. So the answer to this improper integral is 2. So therefore, this converges. Now let's take a look at this example over here. You know that the trouble spot is at 1 because when x equals 1, denominator is 0. And unfortunately, 1 is between 0 to 3. So we have to break this integral into 2 parts, 0 to 1 and 1 to 3. Okay, first, let's focus on finding the antiderivative of this. So let's rewrite it as integral of quantity x minus 1 to the negative 2 over 3 dx. And what's the antiderivative of this? It's going to be quantity x minus 1 to the 1/3. Divide by 1/3, which is the same thing as multiplying by 3, and you need plus c. You could use u sub, but this was a kind of a simple to find. So you might want to try u sub if you want. Now you could rewrite this as limit as c approaches 1 from the left. Because we went from 0 to 1, and 1 is our trouble spot. We have to approach 1 from the left. Of 3 quantity x minus 1 to the 1/3 from 0 to c plus, what about this part? Limit as c goes to 1, now it's 1 to 3, so we need to approach 1 from the right side of quantity 3 times the quantity x minus 1 to the 1/3 from c to 3. So this is our setup to find the answer to this integral. So let's evaluate this. So you end up getting limit as c approaches 1 from the left. You get 3 quantity c minus 1 to the 1/3 minus 3 times negative 1 to 1/3 plus limit as c approaches 1 from the right, 3 times the quantity, plug in 3, you get 2 to the 1/3 minus 3 times the quantity, c minus 1 to 1/3. So what happens as c approaches 1, very close to 1? This thing goes to 0, so you end up getting, okay, what is negative 1 to the power of 1/3, or cube root of negative 1? That's negative 1 times negative 3 is 3, plus, what about over here? You get 3 times 2 to the 1/3. What about when c goes to 1, very close to 1, that goes to 0. So minus 0. So you end up getting 3 plus 3, what is that? That's a cube root of 2. So your final answer will be 3 plus 3 cube root of 2.